Good morning, good afternoon, and good evening, everyone. Thank you for joining us today. It's great to see we have people joining from different countries and different time zones today, and we really appreciate you making time to join us. My name is Kim Meijer. I'm with the Ames marketing team, joining from our office in the Netherlands, and I will be your host during today's webinar. I'd like to welcome you to today's webcast, Prescriptive Analytics in Action. We are going to use a dynamic capacity planning app as our example today, which is just one kind of the many different ways that you can use our platform. Ames can certainly be applied in many other situations as well. This webinar is a follow-up from our Prescriptive Analytics in 20 Minutes webinar. So for those of you who attended that, welcome back and happy to see you again. Today we are going to do a 2-minute refresher of the content from the first Prescriptive Analytics webinar, and then the majority of the time we will be dedicated to showing you a demo of a finished application, as well as how you can really tailor it quickly and easily to your particular situation. It's my pleasure today to introduce our presenters, Gert-Jan and Diane, who are both joining us today from our North American office. Gert-Jan has been working with leading companies, partners, and universities around the world. He also works closely with research organizations like Gartner and has over 2 decades of experience in the prescriptive analytics space. Diane is our modeling expert who helps many of our customers and partners to solve their most challenging problems.
Thank you so much, Kim. Good afternoon, good morning, good evening, everybody. Indeed, from the Seattle office, we'd like to share a presentation with you on the dynamic capacity planning. And as Kim said, it's just one of the applications you can build with AIM, but I think it's a good example to show you a little bit what's going on. But before we do, indeed, let's refresh a little bit what was said today, and I'll do that very quickly. I don't know if I'll make it within the 2 minutes, but just give you a little bit background on where we are from an age perspective. And the chart I showed last time, but I think it's familiar with a lot of people, is the different types of analytics that you can face and that you can use to enhance your business, to improve your decision making, or to understand what actually is happening. And if you look at Ames, Ames is positioned in the bottom part of this chart, the prescriptive analytics space. It's a space where you want to understand what you should do. You want to receive recommended actions and really become a decision support tool. All the other analytics that you see on top of that, the descriptive, diagnostic, and predictive, are very much focused on analyzing data, and you as a human interpret the data and then make decisions on it. Well, if you go to prescriptive, you start modeling your business in rules, and you start to find out what the corners or the options are that you have to your disposal that are not necessarily directly from the data visible. And that's where modeling and optimization comes in place, and therefore Ames is there. I think it's a good way to know where you are, so it gives you a good sense of what to read about it and how you learn more about it as well. Another chart I did not show last time is, I think, also an important one. When you start exercising prescriptive analytics, is you're really going into this space of what we call systems of differentiation, systems of innovation. In fact, it's also a Gartner chart who put it down there. And the systems of differentiation is there because the moment you start to model and start to want to understand what you could do, how you could enhance your business, it's in fact also when you start creating a competitive edge. Because you're going to integrate, for example, your strategy with your model, with your objectives. Or you're going to find out new ways of doing this with the same resources, doing new ways of exercising the business, or maybe relocations, all kinds of stuff that's going on. That's really differentiating yourself from somebody else. The other side of what's happening when you start modeling your business and start to understand what you all could do is, and we see that all the time, you start to innovate as well, because you suddenly have the space and the time to understand all the options and think about, well, what happens if I were to have a strategy, and we'll see that later as well, where I want to have a minimum number of suppliers, for example, for a certain raw material, which you could not have maybe in a specific system that you have right now. Or you want to change your objective from a cost minimization to a cost and customer efficiency optimization object. You can start to think about these type of things, and that's really strategic and it's really innovative as well for your business. And there you can differentiate yourself, innovate yourself, and I think what's very important when you start modeling your business, you can expect more, and it doesn't have to be a compromise, because if you want to model it, if you feel it's needed to become better, you can just add it to the model and change from there. So that's what we show you a little bit of that today as well. And what we have done in the recent years is a new methodology with our clients where we are not wanting to solve the problem all at once and have a customer do big project of 12 to 18 months. What we believe in, you have to start small, have to be lean. And we have this methodology where we start with a 2-day POC, a proof of concept. And this 2-day POC, it's on the right corner here, and that's a focus I want to share today a little bit on. And I mentioned as well in the last webinar, it's within 2 days we want to build a first phase application that it's valuable to your business. But we don't do just building the application, we do it together with the group in the company that are the stakeholders. Think about the management, think about the people who own the finance and need to budget for it, and need to give you the budget for it. But it's also IT, it's the developers inside the company if they're there. It could be a partner if that's the partner that you use. So you want to have the right stakeholders on the table so everybody is on board on the process, on board of the actual problem that you're solving. Is that the most important problem you have right now? And if you're successful, and typically within 2 days you have your first phase application, you can immediately move on from there. So, okay guys, we see this value, let's move on, and you start the project and start integrating it, designing it, and fully executing it. And that process can suddenly be very quick. And because you have a first phase application, you already typically start using. We have customers using it the next day because they already had the value there because they didn't have anything before. And then every day we augmented on top of that. We added new functionality, we added new features, and a little bit of that flexibility we'll show you again today as well. And this 2-day approach, by the way, we do that in 2 days, but what we try to do here and give you in this 40 minutes or so, give you a little bit of a taster of what we typically get to. And we do, of course, on the application side. So looking at the problem, and we picked this problem because it's one that comes up very often. I think a lot of people have this problem. They're looking at, in this case, let's call them factories. You can fill it in for your own business, and I've seen there are many different businesses they're currently attending. So I leave it up for you to map it a little bit to your business. But you have factories where you have production, like produce certain goods, and you have to bring them into the middle warehouse, and the middle warehouse will supply your customers at the end. So what typically happens, the supply chain is split up in 2 parts. The warehouses have a certain demand, so they're ready for the customers. And of course, they need to be delivered out of different production plants, and in this case, factories. So the big question here that we try to solve is, okay, which factories, which production lines, how many of the goods do I produce, and how do I transport them to the warehouses to assure I have the demand that they need? And of course, I want to do that at minimal cost. At least that's the decision we'll make right now. And in the example, we took up 6 factories, 9 pack lines in each factory, 56 different items it can be produced, 30 different warehouses. So if you look at the full scope, if everything would be possible, and that's not the case because not every production line might be holding every item, but you already think about 90,000 combinations by itself. And then of course you have to think about the production volume. So there already you realize, doing this in a spreadsheet, and believe it, we have seen those things also in spreadsheets, which is pretty daunting to make sure that you get to some kind of a solution. It's a daunting task to just do that in a spreadsheet or from the top of your head. You can't do that. You need sophisticated systems. And if you want to differentiate on it, then you need a system that can actually model it and be very flexible to your needs. So we'll show that a little bit today. Before we go in there, just to give you a little bit of indication, what you could do as well is you could decide, of course, to have a rule of thumb. And that also happens because it's very daunting to do it by yourself. So you could think about, okay, let's order the demands from the warehouse on size, largest first, and I service the demand from the cheapest factory nearby. Then I take the cheapest package line. I take the next package line if they don't have any capacity anymore, etc. So you can think about this rule of thumb as something that will give you a first answer. And that could work out, and you could have a solution. And when we started doing it, we already realized we need to stretch it a little bit, but it could work. Give you a first example. However, if you go to optimization, use prescriptive analytics, and it's a term, prescriptive analytics, that's very much used in the US. I realize in EMEA it's less familiar, less used, but it's good to realize that the prescriptive analytics optimization is part of that. It's the one you put recommended actions in. And then we look at 4 different things when we start to model this business. We look at, of course, the objective, and in this case, we look at total cost. What's the minimal cost that we have? What do we want to achieve? We have the decisions to make, and decisions to make is how much to produce, which package line to use, how to transport, or then you have to transport to which warehouse, so which warehouse is supported from which package line, which factory. So those are decisions you have to make. And we have our restrictions, and those could be physical restriction because a pack line doesn't have more capacity. They could also be strategic. I don't have any strategic ones in here, but we'll do that one. We'll add one later. So currently they're all hard constraints. And of course you have your inputs, which is your speed of the production line, or it could be your maximum capacity of a factory, or these type of things. Those are the inputs that you have as well. And if you mix them all up, you know, what you want to have at the end is find the best possible combinations to do that, or get an understanding of what if you change something, what will be the effect. And that's what we'll show again today. Before we go into the actual model and have Deanne open up AIMS and show you under the hood, I want to show you how this typically goes to the end users. So what I'll do here, I'll open up AIMS Pro, and AIMS Pro is our app store. This is an app store that people get on premise, our customers get on premise. Well, we can also offer it in the cloud, but it's your own protected, secured app store. And in this case, you know, I'm logged in as Deanne because I'm in Deanne's machine right now, but she's an end user, or I'm an end user, let's call me the end user here, and I have 3 apps that are at my disposal. And there are many more apps on the platform, but I didn't get access to those. So what I can do here, I can open up the app, and what you see here, it opens up the browser. So it's a web-based application. I'll see the same structure here, and what I can do, I can look into it a little bit. So I'm going to look into the inputs. So here you see scope of demand, all the different products that I have here. I have the different warehouses here, so I can move it back and forth, see all the information. So you already see it's quite large. It's not very easy to understand what exactly I should do from the top of my head. I can go into that. I can even change demand if I wanted to. So I see my inputs of demand. I get my production information. So I see my different factories with my capacity. I see the production line time that I have available on the package lines for every factory. And as you already see here that some package lines are not available on certain factories, so they just don't exist in that factory, so I can of course not produce certain items there. And I get some labor requirements. So these are the inputs that I'm getting out of the system, but I can also change them. So if I were to, for example, say this should be 450,000, I can just change it right there and use that information going forward. So let's just use that rule of thumb. We just made a calculation right in AIMS as well. AIMS is also procedural, so we can make this procedure heuristics inside. So if I calculate it, and this is just to give me a benchmark. I'm getting my first result, the total cost to deliver this, and this is a weekly planning. A weekly plan would cost me 121,000 to deliver. And I get some insights here on the factory 1 production line, production line 2, how much it produces, almost 95,000 items. So very quickly I get this insight. But a little bit the problem, of course, is, okay, I have an answer, but how good is the answer? So that is where optimization comes in play. And I'm still the end user, I can play around with it, but what I can do is just can hit the button, and what it will do now, it will get all the inputs, understand the constraints that I have on capacity and all these type of things, and then it will give me the optimal answer. And here it is, 113,000. So just by adding optimization to my system, I gain $8,000 a week, which is about 400,000 a year. So that's already quite a lot. So that gives me a good insight. And then what I can do, I can look, of course, at the details here, but I can also dive a little bit further in. So let's dive a little bit in. So I see my production. Here you see the exact units of a certain product on a certain package line in a certain factory. I get all those details. And those details, of course, I could also export them to your systems, which could be SAP, or if you want to put it to Excel, you can put it to Excel. There's all kinds of ways which you can do. And of course, I have my details on transportation. And here you see some information, the exact details, or we also calculated the percentage of the supplier that's being used, so the different factories to the warehouse. And I will go back to that a little bit later as well. The other thing what I can do, because I do optimization, I can start to do some what-ifs. And there are many what-ifs I can do. I can have multiple scenarios mixed up together, and I put them next to each other and see what the differences are. But what optimization also gives me, it gives me the marginal improvement of my objectives. And what that means, so here we see the same result. We saw the rule of thumb, previous cost 121, the new cost is 113. But here what you see on this side, I see my factory capacity, but I also see my margins. And what you see here, with every 50,000 of increased capacity, I will gain about 4,700 in cost reduction. And it's not exact because, in fact, it's per extra capacity, it's about 0.5, but we multiply by 50,000. So what you will see, if I would increase my F5 capacity, my factory 5 capacity, I would gain total cost. So it gives me an insight over what would happen. And you can see it here as well, because I go to F5, the total use capacity and the total available capacity is on the same line. So here you see I'm in fact restricting myself. I could be better because apparently that's a cheaper factory. So let's see what happens. So I make that 300,000. I can rerun, re-optimize, and we should expect this to go down. And there we are, it goes down. It doesn't go all the way down because the first unit that I add adds a little bit, and it's decreasing a little bit, but it increased my or decreased my cost with about 3,500 to 4,000, which of course is great because this is the insight I'm getting. I'm getting where my constraint is on my factory and what the effect will be if I would increase it. And this I could use to make some changes further down the road. And similarly, of course, I can look at the line items, package lines, and look at the hours to see the marginal cost as well. And what you see here, my margin improvement would be about 13 if I add an hour of capacity. But since the capacity of the hour is $25, it doesn't really make sense to add it because I would increase the cost of 25, then decrease with 13, so the effect would be close to 0 or even less than 0. So we would not want to do that. So this gives you an example of the capacity problem. It's dynamic in that sense that data can change and you can change data as well. You can make the effects on a changing environment, changing capacities, all this stuff. What I cannot do right now yet is I can change the structure of the model. So that's something we will show you later, but already as an end user I have a lot of flexibility. I can look at the different data sets. So let's look at the hood, under the hood. So what you see here is the AIMS Insight. So we're now flipping from an end user mode who's running an application through the AIMS Pro App Store or platform. We're now going back into the development mode. So please shift modes a little bit, and we don't want to go very technical because that's not so important right now, but we want to give you a little bit of an insight. So on the left side, what you see is an explorer. It's a model explorer. So it gives you the insight of what's behind it. So we can open up the first declaration section. You see here the setup of the inputs. And in fact, the blue bulk on the right is build an structure in AIMS based on the available data and build the optimization model. That's the part we'll show you a little bit here at this moment. So what you see on the left side, you see these blue assets are sets. This is your topology, your warehouse, your packlines, your items, how many you have, and we'll define them and we'll get them out of the data. And we see the structure of the input data, our label array that we saw. The line item mapping is which package line can create which item. The line labor right hours, etc. But let's open up, for example, factory capacity. And here you see the structure. That's it. It's just a symbolic structure, factory capacity per factory in pounds. So we also add some units. Let's look at the Excel file first. So when we started doing this, typically this is how we start also in the POC. We get an Excel file or something else. Somehow we get the data, and here we get the data as the number of factories here. We have 6 factories. We have the warehouses, 30 in total, pack lines, etc. But also we have the input data, like the demand tabs, shows you all the inputs that we saw before, the transport cost, etc. So it's a typical way we get our first data. And in a POC, you don't worry about getting it exactly from all the locations physically and make all the connections. You just want to make sure you have the data right there, readily available. So it's just a reading statement. We point to an Excel book, and then we get the cost and the information all out there. So what we can do now is we can just look at the data very quickly as a developer, and there you see the same data. So I don't have the fancy interface right now, but as a developer I can very quickly get an insight of what's actually available. And even as a developer I could change this data right then and there just to have some insights as well of changes that I would make without having to run it as an end user, which is very helpful. Yeah, we can change that there. But it's just the basic part. So here what we have is just the structure of the problem. We have the input data of the problem, but now the important part starts is we want to start optimizing that. And optimization means we need the decisions. And decisions are called variables in AIMS. So what we see here is a decision variable called production. If we can open that one up. So the production is for every factory, F, every package line, PL, for every item I have to understand how much I have to produce. That was the little bullet that I have on the left side, and I only want to do that when there's a line item mapping available. So that's my condition. I can only produce items that are available on the package line. So this is how I restrict where I produce something. It doesn't make any sense to produce an item I if I cannot produce on a package line in the factory. Of course, it has to be non-negative in the decision, and it's again in pounds. And what we want to optimize is the total cost. So if you could go there, maybe that's my objective, and that's a combination of two: total cost of transport and total cost of labor. And we just split it up so we can also analyze them later. So if we go, for example, to the total transport cost, to the definition of that, Yeah, so you can flip around and back and forth here as a developer. And this is just fairly simple. It's a total transport cost from a factory to a warehouse of every item. And then I think is again defined as something else in the back. But this is how you start setting up your decision variables. And this is how you can in fact see it. Because what also is nice is here the decision variables are all in red. And that will help us well with the constraint builder. So the next part is we have these decisions. So what are the restrictions that we have to uphold to? So let's open, for example, meet demand, a very logical one. So what this says here is all the transportation out of a factory to a warehouse of a certain item has to, of course, meet the demand of that warehouse of an item. And what will happen underneath is that Ames will generate a model that will be solved by one of the solvers, and we use Suplex typically. It will be giving you the optimal answer for transportation to service this warehouse and this. And how it makes it optimal is because we have defined a math program. So if you can go into the math program, the last one here. So what you see here, and that in fact ties everything together, we say we want to have an objective, it's total cost that we showed you before. We want to minimize it in this case. We consider all constraints and all variables that we have defined in the model. And by the way, this is still a very small model, but it's very powerful. It can be much, much larger. Or you can also decide even to say, oh, I have a subset of variables or a subset of constraints. So you can maybe turn on and off certain constraints you have. Suppose you have a security constraint. Let's see what happens if you unsecure it. What can be done? And if we want to optimize it, it's a very simple statement. We have a procedure here that's called solve the least cost dynamic capacity problem, and then we solve, and that's about it. And maybe you can show that. And even as a developer, and we should run into the same problem here, 130,000. So you should see the same answer again. But of course, what we've done before is we publish it as an application that was shown to the end user. So that gives you a little bit of insight of under the hood. So we have the inputs, sets and parameters, and we have the decision that we have to make the variables under the constraints, and then we solve the optimal problem. So what we want to do now is show a little bit how to extend this, because I don't know. Can we go back to the chart again? Oh, sorry, to the application. Mm-hmm. So if we go to this page, and maybe some of you have seen it already. I alluded a little bit to it. We looked at the supplier percentage, and we noticed that warehouse 1 is supplied from factory 1 with 94% and 91% here, which is it's quite a lot. So let me highlight this a little bit. So I'm back in the end user mode here for a moment. So suppose I want to see everything above 90 here, just do it like that. So what you see here, everything above 90 is maybe something I don't really like, or maybe it should even be lower, but at least it tells you that I'm very dependent on one factory. And what happens if this one factory goes down, or something happens on the transportation from that factory? You know, you want to maybe mitigate your risks. But I can't as an end user right now because I don't have the power to do anything. So what we want to do now is we want to go back into the developer mode and add this strategic restriction and say, well, the strategic restriction could be, I want to have at least, at most, say 75 or 80%, and let's start with 75% of a factory delivery to a warehouse. And anything else should come from another warehouse. So I at least have 25% of my demand ready to serve. And of course you can make that number higher or lower, but just to give you an indication. So let's dive into let's go back to the model.
So first thing we want to add here is we introduce another rule. So I want to introduce, okay, what's the maximum percentage we want to allow here? So we call it max factory percent. So here we want it, first it's a percentage, and Herjan mentioned we want to have, for example, 75 as the initial data. So we can check the data, just make sure, okay, it's 75. And then we introduce another rule. It's a constraint since it's a business rule. So we call the supply balance. So that's for each supply from a factory to a warehouse. What we want to do here is make sure for all the item transport out of this factory to the warehouse, all the items should be less than the 75% of the total demand of this item at this warehouse. So times the max factor percentage we just added. And this in the unit of pounds, since all our demand we categorize in pounds. So by doing this, the constraint added.
Yeah, so now we have extended the structure because we had this math program which considered all constraints, so automatically these constraints will be added and we'll use the max factory percent that we just created. And you know what we could do is maybe just do a quick run on this one as well, show the progress. So if we just want to test this, see what happens, and we should see a different objective. And what we see happening here is the objective goes to 115,000, a little bit more than that. So you realize by adding this constraint, we already have a different answer probably, because we saw going up. But also we made sure that restricted the delivery to 75%. So there's a cost, of course, logically, because we cannot be as optimal as we were before. We're less optimal. But at least we mitigated our risk. And the cost of the risk is only 2,000. And it's still farther below the rules of thumb. So let's realize that we have a better model probably. And still at a better cost than the rules of thumb before. And that's all great, but we're still just only a developer in the end, so we don't want to hold it to you alone. So if we want to give this also to the end users, we want to update the application. So what we can do here, we can start going into the web development mode. So it looks very dissimilar because it's what you see is what you get. And let's extend this application. So what we'll add now is we'll add the max percentage also to the tabs or to the pages that we have available, so people can start changing those. So there you see it already there. Let's freshen it up a little bit, add a title to it, so make it a little bit nicer. So you also see here immediately that the UI that you see, the web UI that you see is drag and drop, it's click and search and all these type of things, so make it very easy. So here it is. And already we see a new result because we're in development mode, and can you make it maybe 80% just to see if it really works? Because you never know. It should be a little bit cheaper again. And there we go, it goes to 140. So if you do it at 80%, it's 140, still higher than 113 of course. So this is how you can start playing with it. Still good, we now extended the model, we extended the UI, but of course now we want to also give it to all the end users because we're still in developer mode. So what we can do now is we can start publishing to all the end users. And what AIMS has available for this is what we do, we wrap up your model or the model in a special what we call AIMS pack, and that AIMS pack is, think of it as a special zip file, whatever you call it, and we'll start publishing it on the AIMS Pro App Store, AIMS Pro portal. So what we'll do now is we go out of end user mode and we'll go into the administrative mode. And what you see immediately, this administrative mode has a few more tabs on the top. We don't go through it because it's not the intent of the meeting today. But you see also a lot of more apps than we were assigned to. And we see here we upload this AIMS pack, we give it a new number, and we publish it. And what you see now is we see the 223 that Deanne just created. It's already there in my admin mode. Automatically incorporates all the new access rights. So if I go back to the end user mode of Deanne through Active Directory, you now see the 223 right here, down and there. And what I can start doing now, because Deanne has now extended the model, I can open it up and I should see the new functionality right here. So let's see if that's correct. I still have my inputs. I have my optimization here, 75%. I can optimize it. And there we are, the 115. And of course I can do the same here. So this is how easy, and we said that before by the way, and we can still, let me also test it here, show you here. So if I make this 80%, I can run the optimization. I get a better result, but of course what we truly want to know, did it really help? And what we see here, let me highlight this one now here. So you see the high ones here are all at 80, and this is exactly the boundary that we just gave. And this is how easy it is to have a model that already brings value. You realize you want to maybe mitigate some risk or do something else with your planning, capacity planning in this case. You work with the developer right then and there. He augments the model from a structural point of view, and then you can start using it. Of course, all data changes that you have, you can just do it yourself. You don't need a developer for that, but if you want to have structural changes, of course, you need to start expanding the application a little bit. That's what we wanted to show you from the demo side, under the hood side, give you a good insight on how to change and how to adapt and how to use. So let's go back to the presentation. What we have seen is I think, a few very interesting things. I think it's important when you start doing this is to understand what the value is of prescriptive analytics. How can you make sure you need to do this? What does it bring you as an organization? And we looked at the objective. We already saw that 121 went to 113 a week, which is about 400,000, which is it's great. And to be honest, the objective of the rules of thumb is a little bit a bended one because it's pretty hard to have very, very good heuristics. And already we realized when we build heuristics, we have to stretch a little bit the capacity to make sure we get to an actual feasible solution, because you can run into problems, you have to start swapping stuff, it's very complicated. And you have a fixed rule set, so it's hard to change. And specifically, if your business starts to change, how do you deal with that? So you have to go back in and try to find good heuristics. If you go to optimization, you just do the structure, and it gives you the recommended actions. And it gives you an understanding how good you can be. The optimal solution is 130, so you can be much better than 121. But you also start to understand the improvement options, and I showed that with the marginal cost improvements. And of course, there could be other things that you can add also as marginal cost and see what happens there. You can do your what if. What if I extend the capacity? What if I would have a limitation on the number of suppliers I have? And you have a basis in this case created for capability to promise, and I think that's a very important thing we see here nowadays as well. A lot of our customers are trying to make sure that they can deliver their customers, looking at their demand, looking at their capacity, but they have no way of knowing when the customer calls with a changed order which is much bigger, much less, or a new customer calls in, and we've seen that, for example, a nice case at NAMPAC, where we also have documented online, not knowing if you can deliver the order is an issue. Now you can just add the order and you can see if it still is possible or when it's possible. So you don't have to say no, you can just say when, which is a very big change, of course, for a customer and for your business. And of course, you can extend the DCP model or any other model to reflect new preferences. And again, these are very basic ones, but you can build it as wide and as complex as you like. And that's something you could not do with all the other analytics. So what did we typically do in this structure? We highlighted to build the structure and aims and to build the optimization model. We showed that. We didn't build it in front of you, but we built some changes. Of course, you built the UI, and we've shown you the full UI and started showing you a little bit the extension, but it's all point and click. And then you do the publish and run the app. And I think the demo itself took about 8-9 minutes, but the change itself was about 1.5 minutes and publishing another 1/2 minute. So very quickly you can give your end users the latest and greatest application. And they don't have to worry about running the old one because it's all right out there. And I think that's for us is very, very important, that we give you an ability in our technology that if you have an idea how to improve the business, you can work on it very quickly with your end users to get the insight. You can publish very quickly, you can start bringing benefits to your business in any corner. But it doesn't stop here. And if you look at your supply chain, there are many ways to leverage skills if you start building them up, or if you start using these type of tools, or if you start to use aims. And these are just a few examples. And we now look at the manufacturing production side and the sourcing side, and sometimes these are combined. But there could be planning items, there could be pricing items, transportation items, and they could all have different objectives. Sometimes they're cost related. Sometimes they're revenue related, and the revenue related I think are very, very interesting because cost reduction is of course very, very important. You need to do that, and we tend to see quite some big wins. But if you start to also think about how to increase your revenue, you start to increase the value of your business, and you start to create ability to augment the business, extend the business. And if you look at companies that need to live on new product, which could be in electronics or it could be pharmaceutical or whatever, they need new cash to build new products, new product introductions. And you can only do that by increasing revenue and not just by reduction of cost. Similar market share changes. Pricing, and pricing is kind of a question, is it supply chain or is it not supply chain? But we see those being more tangled into the supply chain. How can I not price it into the market, but also how can I work with the operational side to get the best cost so I can create the best margin? What's the pricing power in the market to set up a new product? What then do I have to do on the operational side to manage my cost? And this integration of different things I think is also very powerful. So, and again, you can just look at these items. There are many more out there, but it's just some indication that you think probably of doing. So with that said, I think we give you a first indication. In the previous webinar, we gave you a few more options as well, but there are many other webinars out there. And if you think, what should I do next? There's next steps for you available. I think a very interesting one, and we've seen every time a big value out of that, is you can work with us to do a proof of concept, work on a problem. And it's important to have a problem. If you don't have a problem, if you don't feel you really have what we sometimes call a burning bridge, there's some blogs about that from one of my colleagues as well about that. It's important to realize as an organization, okay, I feel I can do better, I know I can do better, and I want to go at it, I want to do it. And if you have that and you know where you might want to tackle something, it's fairly easy, and of course, easy is always relative, to sit down, stand behind a whiteboard and start to find with the group, what's actually our problem? What is it that we would love to have that we don't have today? And use that insight to move it into a model. And as you saw before, what Deanna was doing, it's just defining the restrictions that you have, defining the inputs that you have, and defining the decisions that you want to make. And that's that slide that I showed before, the decision, inputs, and restrictions. And then it's a matter of, starting to run it and see what the results are, start to augment and become better. And doing that together is very powerful because you get different insights. We have a lot of insights, of course, from our experience, but you own the business. You know what strategy you want to go after. You know what hurdles you might need to take. And we'd love to work with you on that. So those would be, for us, at this point in time, after the webinars we did before, a very good recommended step.
Thank you very much. We have a first question coming in. That the question states, what is a typical gain you see when people start to use this type of analytics?
Typical gain is always a hard one because it very, very much depends on the type of business. But what we do realize, because what optimization does, it kind of shakes the typical things you do, and therefore we see improvements of 10-20% that are not illogical at all. We've seen a situation just recently with one of our customers while they were doing the POC, and the POC was about deciding on how to go from a local network to a integrated network, that within 2 days they realized they didn't have to do certain strategic moves they were doing. They wanted to build a new packaging line, and they realized by using optimization they didn't have to do that. That saved them $30 million right then and there. Within 2 days. That even surprises us from time to time. So we don't typically talk about 1 or 2%, we talk about substantial percent because it really shakes it. Of course, the devil is in the detail, and also the devil is in the implementation and the follow through. We give you recommended actions, but in the end, it's up to the customer to actually implement them. And sometimes change is hard because you have to think about a changing process, a changing role, maybe an unintuitive answer. An unintuitive answer is something that typically comes out of optimization because we look at the whole scope. And just if I may, another example that I noticed in a logistics company where they were transporting goods around the world, and this was in Asia, and they always went from, I think it was from Singapore to Thailand direct, and the answer certainly was you have to go through Singapore or through Indonesia, and they were like, well, that's stupid, we should never do that. But what happened is that tax breaks and benefits like that were giving them a better advantage if they would have a longer ride with more cost of labor, because it would be offset by the taxes. And taxes is we realize, a very, very important thing to many businesses. Where do you produce? Where do you deliver? If you're able to integrate those type of things into your sales and operation planning models, for example, it can give you many, many benefits.
All right, thank you, Herjan. We have another question coming in that is referring to a slide where you showed the 2 to 8 weeks time frame. And the question is, how realistic is that given that the quality of getting data in from clients is always a challenge and thus causes timelines to slip?
I'm reading along with the question here. Yeah, it's a very good one, and it's a very challenging one. I will not mention what, but well, there are two sides. So one of the things is good prepping. So one of the things when we do the POC, we want to make sure that the people who own the data are there in the room, and they understand their data. We also realize that you have to continue. So if you don't have the data, you don't have the data now anyway. So what would you do if you don't have the data? So you probably, I wouldn't say make up, but you will do your best guess and use that information. And that will give you information next time that you need to get better better information. So it sounds maybe kind of fake. So I don't think, personally, I don't think it doesn't have to hold you. Of course, if you're all just generating fake information, fake is a very loaded term right now in America. Anyway, but it doesn't make any sense. Don't produce results that nobody can understand. But most of the time, people have the data available, and you can start using it and learning from that. So I wouldn't worry too much about it, but make sure that what you need can be brought in and can be made effective. Maybe to add to that, because I see that it started with the 2 to 8 weeks in the question. So it's good to realize this POC is not 2 to 8 weeks. The POC is 2 days. So what happens there, we'll prep with the customers. We'll ask them what kind of data do they have available, if they have a little bit of understanding of the problem, and they have the right people available, and then we work with the data that we have then and there. And then, of course, we realize during testing some data is not fine-tuned enough, or we need a little bit extra, but we have our first indication, our first result, our first value, and then we'll build on top of that. So it's a staged process. And because if I would have to wait, or I think that's the same in organization, if you have to wait till the data is ready, data is never ready, because it changes tomorrow and tomorrow and tomorrow and the day after again, because we always get new data. And I think that's the biggest challenge that a lot of customers or companies face, is they feel they first have to be ready for the data. Well, I don't believe that they ever will be ready for the data. You better get started. And look at all the data lakes initiatives, the big data initiatives. Okay, let's gather. Well, I think there's always sufficient to start going at it.
All right, very nice. So for now, I'd like to thank everyone for joining us. And we hope you enjoyed the information that was presented today. And a big thank you to our presenters, Gert-Jan and Diane, for giving us a very informative webinar. If you still have any questions after this webinar, please feel free to reach out to us directly. We'll personally get back to you, or make sure that one of our other experts will follow up with you. And you can see our details here on the slide. So thanks everyone, thanks Diane, Gert-Jan, and have a great rest of your day.